this to really make it some pretty cool things. All right, so examples for atomic transfers might be simplified expedited settlement, efficient matched funding, reduced counterparty risk, enable any multilateral trade as well as circular trades and group payments. And you can combine these with ASA or smart contracts, which we'll talk about next. It's a settlement for complex and multi-party transaction and distributed payments. So we have smart contracts. The language it's done is called TEAL. It stands for Transaction Execution Approval Language. It's like an assembler language, and you think about it, this has got to be very performant. And there's nothing more performant than that type of a language. It gets very expensive to host VMs on a blockchain, and that's part of the problems we've had in the past with other blockchains is the performance, right? Really gets bogged down with that approach. There is also a Python-enabled compiler called PyTeal that you can write it in Python and then use a compiler and it'll generate the TEAL for you. And there's another tool I'm going to show at the end, which is Algorand, and it has a lot of tools as well for generating templates and things of that nature in TEAL. There's two types of smart contracts. One of them is stateless and the other one's stateful. So the stateless is great for approving spending transactions, and stateful also facilitates global storage on the blockchain as well as local storage at the account level. So it's combinable with other Algorand technologies, with atomic transfers, Algorand assets. You can even combine stateless and stateful contracts together. So the smart contract value in the financial industry, allowing you to do trade finance, provides clearing and settlement capabilities, financial data recording, you got digital identity. And then in DeFi, like we talked about up front, escrow accounts, managing payments, lending and credit, and stable coins are very huge. So these are all things that this facilitates. Algorand accounts, let's talk about this now. There's three types. There's a standalone account, a multi-sig account, or multi-signature is what that stands for, and a logic account, which is what's facilitated with smart contracts. So you see the little keys on there. There's a public and a private key on the standard account. And then the multi-signature account requires a threshold out of a group of accounts. You define whatever the threshold is for that group. Say you have 5 in a group and you want 3 to be the threshold. So 3 of the accounts in that multi-signature account need to sign it. And then once the threshold is met, then it'll be approved. That's how that works. It's very analogous to you take a check to the bank, and sometimes checks require 2 signatures on it. Same type of thing. You got to have at least 2 signatures. In that case, the threshold would be true for them to cash that check. And then you have what's called an LSIG sometimes, or a logic SIG account, which the logic of a TEAL app returns true or false. So if it returns true, it'll sign it. If it returns false, it won't. And that's how that works. Rekeying is also a very important thing. So let's talk about public and private keys. First of all, a public key, you want everybody to have that. That's how you're going to get money. You're going to be able to, say, okay, send me some money or assets or algos. Here's my public key. But the private key, on the other hand, is the one you want to put on your, your device here, your Nano, or you want to put it on paper or stick it in your, safety deposit box or whatever. You do not want those on your computer. You do not want those in email. You don't want those accessible to the internet, period. So what do you do if you have to change the private key, right? So that's kind of what the public and private key is all about. It's a cryptographic key pair. So on the left, you can see they're tied together, the public and the private key. So rekeying separates this process by assigning others that would be authorized to approve transactions. So there's another account that would be able to sign off on it, basically. So the middle diagram separates those two keys. Now this is useful because sometimes you're growing, you know, and first in your organization, and first you start out with a single signature, a single account. Now maybe you get a board of directors and you want to expand that to a multi-signature account. Well, until this feature came out, which is fairly recent, we had it a few months ago, came out, that was difficult to do. You had to basically recreate another account, recreate another set of private keys, and it was a mess. So now you have the ability to do that, and you can see the authorized field there on the upper right, authorized address field, now is wired into that standard account for the spending key. All right, so that's kind of the intro on accounts and signing and rekeying. What I want to do is I got a couple scenarios here on solutions. And remember I said we can combine a lot of these features on layer one. Let's take a look at a voting example. And we have these solutions written up on our developer portal. You have a voting commission account with a spending token you want to get. And then these are going to be all atomically grouped, right? So all of this works or none of this does. Then you vote for candidate day A, and then there's a voting smart contract that makes sure that this thing is legit. And once it's a legit, it'll increment candidate vote total up on global state on the blockchain. So that's the whole scenario right there. So if for some reason the contract doesn't work, then this vote never happened, right? And then you would go back and make that happen. Crowdfunding, another popular solution for blockchain, and this is really becoming, I think, the de facto standard for crowdfunding type scenarios. You have crowdfunding escrow account with a stateless smart contract going to a payment for a user. Once again, these are all atomically grouped. And then user one claims the escrow funds once that escrow fundraising has been met. And the smart contract would be a stateful one that might determine that down below and a stateless one up on top. So once again, those that joined late, we are running a contest here today to win a $100 Amazon gift card. So we've got about 30 participants now. And it is a cool newsletter. Ryan actually publishes that on a weekly basis, and it tells you everything new that's going on in our developer site. So go ahead and take a picture of that if you joined late, and go out to our site and just sign up. You can go out to the developer portal and click on newsletter in the bottom footer. All right, I'm going to open up the floor here. Anybody got any comments or questions or anything? Or Ryan, we got anything there to share?
Nothing to share in the chat. We've answered the questions and posted in the links as you've gone through there. So let's encourage people to unmute their mic and ask some questions.
All right. This is your opportunity. Anybody go ahead and want to participate?
I got a quick one. What's the difference between Algorand and, say, the Graph platform?
I'm not familiar with the Graph platform. Are you, Ryan?
The Graph platform or Graph database? Maybe I didn't hear the entire question.
The Graph, GRT, the Graph.
I'm sorry, no, I'm not familiar.
Wow.
What's your take on it? What's your, why? I mean, why are you asking?
A lot of similar functions. I was just curious what the difference between the two platforms are. It's also a smart contract facilitator and crypto backed by crypto coins.
Oh, okay. So it's its own blockchain?
It runs, it seems like it runs similar to this, just you guys have everything built into the algo stack itself, and these things, and the Graph kind of is the API that ties into the IPFS system.
Oh, I see. Okay. All right.
It seems
I'll have to look into it.
It seems like a fast spin up, repository spin up. They run the models through Git. It seems a little similar, but it's I was just wondering if you guys knew about it. There you go. I just saw something flash up on the screen, but I love
Okay.
this information. I thank you guys a bunch for sharing.
Oh
Definitely.
yeah, my pleasure. The best part's yet to come here in this next session.
Very informative.
Oh, great, great. Anybody else got a question?
Well, Red had a question in the chat about COVID app, and I posted in the link there, which is ireport.algorand.org, which is the foundation's, the Algorand Foundation's COVID-19 tracking app. So yes, it's out there, and certainly putting this type of information and making attestations for different types of data and posting to the blockchain is definitely one of the use cases that we see adoption for.
Cool. And I'm glad you said the foundation. That reminded me to, there are two organizations. One is Algorand Inc., who Ryan and I work for. That's the technology side of the house. And then there's the Algorand Foundation, which is responsible for token economics. And so anything with token distribution is the responsibility of the Algorand Foundation. I'll be going through some of the grant programs and things like that they have available toward the end, but there's a lot of really great routes for folks to, especially developers, to get on board and get a little extra cash for yourself as well in the process. So let's continue on then and go through developer tools, unless someone else has got a burning question right now. I'll take one more. I like the interaction. This is great.
Didn't see anything else come in, Russ.
All right, here we go. Algorand developer tools. So we've got a great developer portal. In fact, hot off the press, we just won this. We won a Debbie Award from Developer Week for Best Innovation in Blockchain, specifically for the developer portal. And so it just goes to show you we're being recognized now in the industry, and lots of great documentation out there. We've got a lot of feature guides, how to install and run nodes, a lot of great reference documentation. Let's just take a quick peek. All right, so this is the, and we even have a new metrics button here we just added. So you can see all the transactions per second, the addresses, the blocks, how many different assets are out there, and, you know, some really cool graphs and charts. So you can see, you know, really everything that's going on there. Then we've got some really great documentation. I want to point you to this to get started. You just go to Start Building, and we'll give you the lay of the land here in terms of setting up your environment, and then also connecting to a node. And I'll talk more about the connecting to a node as well. But basically, these first three steps is what you want to do. And by the time you're doing the third step, you're actually doing a transaction through one of our SDKs. Each one of these has different languages like Go, Java, Python, JavaScript samples are all in these tabs, as well as at the bottom, typically there is an example for a link to the code, and you can see all the samples right there as well. So that is, and then we get to building applications. This is starting to cover more of the smart contract stuff. And so really good to go through this as well. Feature guide. For example, you want to look at creating an account. These are the creation methods. There's a way to create like a standalone account, for example, here programmatically. I'll actually show you that in the demo. And then we got assets, atomic transfer, smart contracts, how you do each of these. There's, we also have an indexer, which is good for searching the blockchain. And then tutorials, a lot of great tutorials out there. I actually did some on using VS Code. With JavaScript and C# and Go and Java, for example, and there's a lot of ones around building assets. These all are step-by-step. So here's one right here on Algorand Builder. That's another great tool from the community. In fact, we just did a developer office hours last week on that. We run those every other week on Tuesday, and I'll give you the link on that too as well. You're welcome to join. I'll be doing I just did one yesterday on Indexer, and next week we got one on Algodia, which is the last demo today. Very, very cool stuff. So anyway, I like the hard hat. Anybody knows me from before, I used to be Russ of Russ's Tool Shed for Microsoft, so I always dressed like that. So I kind of like that. But anyway, these are all step by step.
One thing, may I interject in there on on your tutorial piece as well, and remind this group that when they click on the tutorials that they can filter specifically for JavaScript. So all the different languages are there, but if they want to just specifically for JavaScript, they can filter on that one.
Yeah, there it is. So yeah, that's a very good point. Thanks. So there you can see the sort by language as well as level. So some good things there. All right, if you want to contribute, there's a button there. We have more and more community members. Bello here, he's been out in the community doing a lot of great stuff. This is by Robert. He actually did the session last week for us too on Algorand Builder. He wrote it. So a lot of great content. Also, in addition to tutorials, we have solutions. A lot of folks know, is there a solution for, let's do a type in here, CRM. See if we come up with anything. No, that's empty. All right, so we don't have any, don't remember anything on that. I was just taking a chance, but there you can see that. And also we got some great articles, just pieces of information that are very fruitful, and the forums to go out to. So this is the lay of the land for the developer portal. So we have 3 networks. One is mainnet. That's production. Testnet is a mirror of that. And there's also BetaNet that we use for rolling out new releases. And there's a private network that you can run, which is private to your own machine. I like to refer to that as a personal network. So I like to use a personal network when we're going through rapid changes in BetaNet. So I like to create basically a copy of that BetaNet, keep it on mine so no more changes are done, and I could do my testing in BetaNet until I'm ready to move on to the next testing suite. So and then BetaNet also is really all about the newest protocol level features. So whenever we do an update to the protocol, that's where we test it out first. Testnet and mainnet get rolled out at the same time. Those are mirrors. The idea is that if it works in testnet, it'll work in mainnet. So it's the exact same protocol in each of those environments. And then once you get started setting up your node, you've got the ability to create nodes on a Mac, Ubuntu, other Linux distros, example, Raspberry Pi. You can actually do it on Windows now too. I got to update this slide. That was a community contribution to our blockchain. This used to take several hours to build your own now, but now there's another feature called fast catch-up, and within minutes, your node will be ready to go, and you can start using it to do transactions. PureStake and Rand Labs do have API services. They're both indexed and archived. If you build your own indexer, we're going to talk about that, you cannot use fast catch-up. You have to use a completely archived node, which could take a while. But the moral of the story is here, you can access these from the SDK code on platforms that do not have nodes. So I wrote, one of my tutorials was using Xamarin, and I built a iOS Android app solution. And so from that, you can access that code from those platforms. And I used examples in there for PureStake, as well as the sandbox, which I'm going to talk about in a little bit as well. But that's a great example of maybe using PureStake or Rand Labs API service would be in a mobile app, because you don't maybe have access to a server on your phone, right? So that's a great way to do it. Sandbox is excellent. This is a Docker instance. Typically, it's not used for production because you can reset it at any time. But basically, it's a snapshot, and there's really little sync time. And you can run this on Windows as well. Okay, so then we got, how do I get started right with Sandbox? Well, you install Docker, you clone the Sandbox. Now it defaults to the private network with Sandbox up. So it will go ahead and for testnet, you would do Sandbox up testnet, and you can do mainnet and BetaNet as well. Those are all supported. So we did a video. Ryan actually delivered the session up on YouTube, where our YouTube channel is youtube.com/Algorand. And this is a picture of the README file. What you need to do programming wise when you start using the SDKs is you need the address of a node and the token of that particular node. And that is how you get going. And the code you'll see in a minute utilizes that. And for Sandbox, it always goes to localhost 4001, all A's. KMD is another daemon we have. That's a wallet, kind of like a cloud-based wallet. And then it's really good for testing wallet type scenarios. But I would use Algo Signer, for wallet interaction, as well as you got Indexer down below. So Indexer is very, very interesting. And so now you get that by default with Sandbox too. We covered that. And then we have 4 SDKs, like I mentioned, Go, Java, JavaScript, and Python. We also do have a C# SDK that just got upgraded and is current. So any C# devs out there, if you replied on that. How do you install a node? Well, how do you install an SDK, I should say. And we've got a really nice document here under our SDK reference guide. And for each language, it shows you what to do to run NPM there. This is a list to see what the current version is. And we got these client instantiations. How do you instantiate a client right here too? And this is for each language is right there. So get you going real easy once you install your SDK. We do have dispensers, right? So when you're running testnet, you'll need to dispense funds to a newly created account.
So cool. You can skate on the water.
Yeah, so you can see that you will be able to dispense funds to cover things like transaction fees. And so these are dispensers that are available to do that. So let's take a look at our first coding demo here. We're going to create accounts and dispense funds to that account, and then we'll do our first transaction. So here is a solution. I'm just going to run it. I've got the breakpoints already set, and this is in our favorite language here tonight. These are all going to be in JavaScript. And so here we go. So now I hit it right there. So what I've done up above here is I have created and generated 3 accounts, and account 1, account 2, and account 3. And I printed off the information down below with the mnemonics as well as the addresses. So for example, what I would do is copy that address, and we're going to need that in a minute, but this is where I want to point you to first. This is using the sandbox. So there you can see the token, the server. This instantiates the client. Now I'm off and running. So I've got client functions I could utilize, as well as functions from the SDK, which is brought in right at the top here. So this Algorand SDK, anything basically to do with secret keys and doesn't go across the wire would be using the SDK versus the client. And so, for example, to create an account which deals with secret keys, you'd be using the Algo SDK, and there's the secret key to mnemonic, and there's the secret key that is cryptic. And then, so I'm just going to continue running this straight through. Let's go out to the dispenser. And so on the dispenser, we need to put some funds in there. So this is how you do it. You just paste that address that we copied off. Now this account is ready to rock and roll. I can start sending algos in testnet. So that's it. Very, very simple to do. So once you got your accounts created, let's go bring in the next one, which is going to be, whoop, that's another demo. Get rid of this one here is going to be here. My bad. Okay. All right. So let's do our first transaction right here. And once again, I'll hit the breakpoints I've got in here. And what I've done here is I have used the note field that we talked about. And the note field is right there. And I'm going to encode this hello world string on it. Then I'm going to make a payment. I'm going to send from the account here called my account to the receiver, which I got specified up here. Now this my account, you've got to have the spending key in order to do that. And the way you get that is you, in this case, these examples restore that passphrase we talked about, and that then creates the my account variable where you've got the secret key available to do the transactions. So there's the secret key right there in bytes. All right, so this is ready to go. We'll continue on here. We're going to make the payment next. And then we want to sign it with the secret key from the sender. And this step here is the important one, send raw transaction. This will broadcast it to the network. And what this does is we're going to wait for the confirmation on this. And once this confirms, we'll have the transaction ID come back, and there it is. Now it's just completed executing and running, and we can see that information down on the debug console as well. So this wait for confirmation is the guy that says, okay, do you have enough funds to cover this particular transaction? If you do, and you're not double spending in any other scenario like that, then it'll go ahead and it'll get approved and written out to the blockchain. That's the sequence. Every time you do a transaction, what you want to do is you want to make the payment transaction itself, then you want to sign it right here, and then you want to do a send to the network. So those are the 3 steps that you would need to code this up. So it's not too bad. We got a transaction here with 100 lines of code pretty much that does that. All right, let's get back out to the next demo is going to be multi-sig transaction. So let's show you that. All right. All right, so the first part of this, we've restored 3 accounts. So we've got 3 accounts restored. And what we want to do here is set up our multi-sig account. And the multi-sig account is going to consist of all 3 of those. And what we're saying is we want a threshold of 2 on that. And then there's a version number that's associated. So any 2 of these that sign off and then you broadcast it will be written to the blockchain. So the next step is to take and get that multi-sig address. So we're going to create the multi-sig address from those parms. Let's just step over that and we can write that out to the console, which we see down below. So here it is, multi-sig address. So what you want to do is make sure that that account is funded. And it will be the same every time if this is done in the same order, right? The same a threshold, the same addresses in that order. And then because what's going to happen is the multi-sig address is going to be the one that's going to be sending the funds out. So then what we'll do is the same thing. Then we'll go ahead and get, these are transaction parms that we use in on the call. And you can see those get passed in as a parameter over here on the right. And you can see things like the first round, the last round, it's got to be within a 1,000 round range. You've got the Genesis ID, so you know you're working on testnet, and the fee, right? If there's any fees that are incorporated. So we got, or if it's a flat fee or not. So let's go ahead and set the flat fee up, and that is now, set. So if I hover that now, it's been set, right? So we got flat fee equals true, and we got 1,000 is the flat fee. Now we're going to do the same thing with the hello world, and the rest of it is actually the same, except that what we're going to do is we're going to do a couple signings, right? The first one's going to be account 1, and then we're going to append to that transaction the signing from account 2, which is right here. And you can see this is the append multi-sig transaction. So now we got both of them signed off, and the send raw transaction will say, okay, this all makes sense. It does. Then it's going to go ahead and fire that off and write that to the blockchain. And that is where we are are done with that. Okay, so there it is. It all fired up where we're going to send the raw transaction now. And then this will go ahead and write it out to the blockchain. So that is a multi-sig example. And then atomic transactions will be next. Let's go show you atomic transfers. There it is. No, there it is. Let's take a look at this. So we're going to recover 3 accounts. And there we have 2 transactions that we're signing. So what we want to do here is we want to send from account A to this receiver account, which begins with GD, 1 algo. And also we want to send from B, account B, an algo. And we want to have both of these succeed. So we're combining both of these transactions into a transaction group and get the group, both those transactions by assigning, getting the group ID. And the group ID is what's used in the transaction. And then we'll go ahead and sign both of those. And then once that's done, we get down to over here, which is where we're going to send the raw transaction. And that goes out to the network. So that's how you accommodate atomic transfers by saying, okay, the first one's got to work and the second one's got to work, and then we're good to go. All right, any questions on any of these things before we get to smart contracts?
Nothing in the queue, Russ.
Okay. Excuse me 1 second. All right, I'm back. I had to get a little throat disc. All right, very good. So moving on to a very interesting area now are smart contracts. So the stateless version of these replaces the signing of transactions. So just like we had accounts sign transactions or a multi-sig account sign a transaction, now a logic account, if it returns true, we'll be able to sign a transaction. So a logic account is any transaction sent from this account will be verified by the predefined logic. This is typically good for things like escrow accounts, payments, split payments, HTL, hash time lock contracts is another good example. The logic signature, any transactions are signed with the signature will be verified predefined logic, or in other words, a delegated authority. So not only does the contract have to return true, but also it needs an account sign off as well. It needs both of those things. These are good for things like recurring payments. So let's take a look at one of these. I'm going to show you the contract account. All right, so on this, what we're going to do is, oops, this is the wrong one. My bad. Let me stop this. Contract account. Okay, no, it is. Okay, here we go. So I'm going to show you is a couple things in this. Number one, I'm going to read in a sample teal program, and I have that right here. Show you that. It's very simple, just int 0, right? So that's going to come back, and that is what we're going to use here. And so that'll return back 0. And this will then step through this. And what we're going to do is compile that. So we're going to read it in. We're going to compile that that program that we have in our from our file that we read in. And once that's done, we're going to use that as an argument for the transaction later on. So right down below, you can see this is the hash or the address for that smart contract. And this is the contract address that you would need to populate with funds if you were going to be having it send based on a true value. It's not going to have, this example is not going to use any arguments. You can pass arguments into smart contracts. Actually, this one is going to be calling, I think I brought up sample teal. What I really should have brought up was sample teal arg. This is the one we're actually using. And it's just going to compare the argument that comes in if it's equal to this integer 1, 2, 3, 4, 5. So now what I'm going to do is go back over to that. I'll continue here. And I'm going to make a logic sig based off of the args that are passed in as well as the program. So there we're going to send 10,000 micro algos. We are not going to use a note field this time, and we're just going to have a sender, receiver, and an amount. And basically, now what we're going to do to sign it is use the sign logic sig transaction object here. And then we use the send raw transaction at the end. But that's the one that's used, the sign logic method in the Algos SDK is used to go ahead and sign that off. So now we'll go ahead and continue on here. And this was successful. It did a match. It matched what we were sending in as an argument as to what it is testing in the teal application. So that's it there on that one. And the delegated account will be very simple, and I'll show you that in a little bit. So let's talk about smart contract life cycles. You get the ability to create an application, opt in or participate in local storage. No op is actually calling the application, and then you have update the application, delete the application, close out the application, and then clear state will always clear. And close out, the teal logic must be true to close it out. So that's the life cycle. So all these can be done, and there's a good link there to do that. When it comes to debugging, basically what we do for debugging is you would wrap 3 things into a dry run request. One is a account information, the signed transaction, and something that's called the approval program, and the program that's going to be running for the smart contract. Then what you do is there's a debugger called teal debug, and you would run that, and then you'd be able to debug it in Chrome inspect. Here you can see a screenshot of that. You can set breakpoints, step right through, see what's on the stack, and utilize that. I'm going to do an example now of a distributed exchange or a DEX. And actually, let me talk about this a little bit first. Let me go ahead and show you the scenario. Okay, so Bob wants to buy asset A, and he's willing to pay X algos per asset A. He wants to spend at least a minimum amount on algos and wants to spend no more than the max. So the solution is a stateless contract limit order to start with. And then the stateless contracts do not live on the blockchain. They must be supplied anytime the contract is needed. The problem is it's not discoverable, and it must be handled by a layer 2 app. This again, it's not on the blockchain. So you bake in logic into the stateless contract, you require a call to the stateful app. So the stateless one is going to call the stateful one. That's the scenario. And does not solve the requirement to have the stateless logic, but it does make it discoverable because now that particular contract is on it. So let's go ahead and take a look at this demo. And once again, this is the architecture. We got a web app we're going to show you this time. It's going to write to storage. We got embedded stateless contract here as well. And then what we're going to do is invoke the stateful contract on the Algorand blockchain. So let's show you how this works. And we'll go over to this one here. So let's go ahead and run this. Here it comes. Okay, so what I want to do here, first and foremost, is I'm going to place an order. And now this is going to place an order. So you can see the asset ID I'm working with, the minimum amount we talked about, the maximum amount, and this is a ratio, and is the N units per asset per D micro algos. So you get 1 asset per 10,000 micro algos. So it's a 1 10,000th ratio. The order has been completed, comes up here. Now we're going to, you know, if I were to place this order again, what's going to hit is the logic that gets rejected by the approval program. When you see an approval program, that's a stateful contract that is doing that logic. So I can't put another request in, so it catches that. Then what I'm going to do is refresh the orders. This is going to go up against index server and get a list of open orders. So I'm going to click on that one. And then if I, for example, we wanted to spend, say, 1 to 10,000. If I make this 20,000 right here and hit execute order, it's going to give me a teal runtime encountered error. Now this is being done by a stateless. Anytime you see a teal runtime error, or specifically rejected by logic, like you saw, you didn't see it the last time, but if I had changed that number, that 1, 2, 3, 4, 5, and compared it to something else, you would have got a rejected by logic message, just like that. So what I'm going to do is make this in the ratio that is requested. We're going to refresh the orders again, bring that up and execute that order. And now that's going to be a success. And then finally, if I did have any outstanding orders left, I can click on it here and close order, but that automatically took it off the queue. So let's take a look at some of the logic in this. All right, so the first thing we'll take a look at is, let's go right down to the bottom of this. All right, so this was the open order method that we called, it's called. So what we're going to do here is simply come down over here. This is the logic that interacts with the server. We got a PHP server running here on this one. Then what we're going to do is call a method here to make the logic sig right there. So now sign it with the logic signature on that particular account. So that is going to be done in this particular function for opening the orders. Now, right above it is one for the opt out. And we didn't talk about opt in or opt out, but you need to opt in and out, or you need to opt in to accept those assets. And this is the one we use to execute the order. And we went through this, and then we went to go ahead and do the logic SID from that particular routine, and this will go ahead and execute it. And then finally, these are all done. This is all done in Dex.js. This is all on the website. Now, this is behind the, HTML, what's going on. And then this section here does a list on open orders. So this one here is actually going to search accounts using the indexer client. And so now this is going to search it for that particular application ID. And the application ID is what we had done in the stateful contract. And then if you look at the this one, the next one here. If you look at the teal, that does the stateful contract. This is basically what you see here. And if you hover over some of these things like type enum, it comes up with the tip. And I got that because under the extensions, there is an Algorand VS Code extension. So, install that, and then you'll get things that make more sense. And if you hover over any of these things that are in yellow, it'll give you a tip on one of those here in this browser. So this basically is a stack-oriented language. For example, I can come down to a section here to check and see what's being passed in. right here. So this is where you have the number of arguments that are being passed. It's going to take 2 arguments, what action to do, right? Open, close, or execute, and then the order number is the second argument. So a test here for the first argument to see if it's open. If it is, you go to the open label, or close, or execute. So any of those would branch accordingly to like these labels right down here. So this would be used for open. So that's kind of like a high level overview of this, but I wanted to give you kind of a more of a real world example that ties all these together. And so let's talk about index server next. All right, so basically this diagram says it all. You have an Algorand blockchain on the right. The AlgoD process is what's going to be accessed to build a database. The database is a PostgreSQL database. So it makes sense, right? You want to do robust queries, you get an actual database to do that against, not a blockchain database. And so this will get populated as the node is running. So these are all accessible from all of these SDKs on top, plus the C# SDK as well. And you can have different choices here. You can build your own. And we have documentation that points to do that. Very time consuming, probably take 4 days to get that built. You can use it as a service, both PureStake and Explore.io have that. Or you can use a sandbox, which is the easiest way for developers, and use the default for private network, which includes an indexer indents. Also, we've got your own REST APIs with this. And for example, we've got a run-in Postman here, for example, on Indexer, as well as I got a run-in Postman for V2, or you can do curl commands if you want to test that out, because with private network, you do not have the explorers like you do like with testnet. So this is, maybe how you might be doing your queries. So I'm going to bring up the Postman. It's spinning up right now. And then it's going to load that new instance into a brand new collection. And then you could go ahead and then search on accounts, for example. So I'm going to, this is, and send this. So searching for an application ID that's on accounts. And that was not the one I wanted to show. I wanted to show, this is the one I wanted to show right here. So the account information is very robust. And if I bring this up full screen here, what you can see is everything that's in here. So this is actually a transaction that's coming back, and all the information that's associated with the transaction. On the account one, if I send this over, now you can see I've got assets that are associated with that account, and these are holdings. These people have opted in, and they have a balance of that particular asset. And so there's a bunch of these that might be associated with the account. Then also you've got created apps, which are the stateful apps that we looked at. And then we have created assets. So this is the creator account that created these. Remember, we saw all those addresses that were done with that AlgoDesk tool. So those are all the ones that are created, and there would be a similar one for just those that have opted in to the apps. So that's kind of the lay of the land there, and using one of the tools that's built right in for you there to do queries on Sandbox. All right, we also have the Algorand wallet, so you can download that from your App Store or Google Play. Nanolex ledger support, test and mainnet settings for developers, rekey to do that ledger is available, and then you have asset support as well. I showed you the community page. There's a lot of great things on that, and all of these community projects I'm about to show you are fairly new and pretty cool. So Reach is the first one we're going to talk about. It's basically a blockchain agnostic tool, and you write it once with one set of code in JavaScript and a Reach language, and then you could deploy it to both Ethereum and Algorand. and they're going to be going to more blockchains. Also, they just announced a couple of days ago, they're going beyond JavaScript. They have support for Go, I think Java, and Rust was another one that they provided. It's got its own compiler and outputs to any chain. It's just a configuration change, and mathematically guarantees safety, outputs the entire application, not just a smart contract, and it deploys, right, and runs simulation tests. Then there is the API for AlgoSigner. This is available to integrate with your in JavaScript. So there's API calls right to the AlgoSigner that I showed. And this is the coolest thing, I think, right here is this Algodia, and it's a IntelliJ plugin IDE. And it creates stateless and stateful contracts directly to the IDE. You got asset management, test account management. It's really great. We're doing a session on that on the 23rd at noon Eastern Standard Time. So make sure you sign up for that on our developer page. So let's take a look at these. The first one we'll show you is a very quick one. This is the AlgoSigner API. Here's the JavaScript on the right. So this just checks to see if it's installed. The plugin's installed. It says, yep, it's installed. Then we want to connect. We're going to use the AlgoSigner connect method here. And then they'll go ahead. Now I'm connected, and now let's get those accounts that are in my testnet environment. And there they are. They come back listed. And what's the status? Gives you back your block status. So these are all API calls that you have, and you can put in, you know, the Rust coin one here. Let's get 10 of these, and then look for those assets. And there's those assets come back. So pretty cool thing in terms of building solutions. Now let's go to Reach, and I'm going to bring up Reach. So I've got two terminals opened up, and what I'm going to do is I'm going to fire up a rock, paper, scissors games, and then we're going to look at the code that was used to build this. So are you Alice? Yes, I'm going to be Alice. Would you like to create an account? Yes. And this is going to be no over here. And we'll create an account for him too. And then now you want to deploy a contract over here. We're going to say, yes, I want to do it. I want to be, the contract is what, you know, guides the rules to the game. And so we're going to do that for Alice, but we're going to use that contract from Alice to play the game. That's the game, right? So we're going to say no here for Bob. Now, this is the contract, and this will look different if you're running for Algorand, which we are here, or Ethereum. Will be a different thing. And so now we're going to paste the contract information in there. And then how much do you want to wager? There's even a little betting going on here. And so we got 10. This is in micro algos, is what it says over here. And then it should ask for the move next once it does that. So it's going to go ahead. Do you accept the wager? Yes, I do. And we'll come back over here to Alice, and we'll go ahead and play the game. All right, so let's do rock. Let's do rock over here, and let's do paper here. So I'm not sure if we'll take it there with the backspace. We'll find out. So, oh, there it is. We're going to play paper. I guess it doesn't. Backspace doesn't work in this game. All right, so now it's going to calculate and see who won. And of course, paper covers rock. So we all know this game. And we're expecting Bob to win. And so that'll come back momentarily, and we'll see that on the bottom. There it is. So Bob wins, and there's the balances that are displayed. So let's go ahead and talk about the code here, first of all. So when we look here, is you've got this, this is the reach file, and it starts out with identifying the reach program on top. And then if we go down the line 39, We see the export statement there, and that line defines the main export for the program. So when you compile this, is what that's what the compiler will look like. And then on line 42, you got the participants, Alice and Bob, that we're defining. And line 43 binds A and B to those participants. We use that in the code. And the shell is slimmer for JavaScript. So now we can see the JavaScript method here that kicks in. And up on the top, let's take a look right from the top. There's on line 1 is the library it's going to load in. Then line 2 has the backend. So basically, you're referencing the backend that was built from the compilation. And this is the front end, is the way you can look at it in the JavaScript. All right. So this is going to have all the prompts in it, is the JavaScript. And then line 6 is the standard library that is used to load right there based on the reach connector mode environment variable. And then lines 7 through 47 are all the prompts. Line 21 in there does the new account test with the amount for that particular account. And 36 is the line here that deploys it to the back end onto the blockchain. And then we get the contract info right here. And then that's the string that got displayed we saw when we were playing the game that we had to copy over. And 48 then defines the, gets the balance, right, for that account, and you're off and running. Now, how do you make this deploy over to Ethereum? All you got to do is go down, and right now, this line here, 59, has a default app. And that is going, that's going to Algo. That's going to Algorand. All I got to do is cut that from that line and go up to line 32, I think it is, right here. And you can see this is the ETH, and you would just paste it right there. And that's all you got to do is one setting change, and then you can run this exact application to go to Ethereum. All right, the final demo of the evening, just on time, is going to be Algo Dia. So let's bring that up now. Okay, starting this up. So this is a pretty cool tool in that it is a plugin for the IntelliJ IDE, and it's loading my project up. And what you see here is an Algorand Explorer on the right-hand side that's filling in. And this is the local SDK. So these are the binaries you download when you do a node. You can specify nodes. You just add a new node right there. You specify the the token and the server name, and then you have that accessible. So you can do different nodes here for testnet, mainnet, PureStake, local, all those. If you right mouse click on here, you got an Algorand tab for accounts. Remember we did that create accounts with code? Well, now you got an IDE to do it, and you could create a new account. Let's give it a name, blah, and then hit OK. And then here's your mnemonic, right? And your address. How easy is that? Then you would just take this address, once again, copy it off and go dispense funds. The other thing, which is very nice here now, is for example, say I want to add in a teal program. I right mouse click, I do new teal, and now you got choices, right? You could do dynamic fees. These are templates, right? So let's look at an order template, limit order template. We got to give it a name. And now this gives you teal ready to go. This also supports PyTeal, right? If I have a PyTeal, I can do a new PyTeal, and it'll give you some choices there. This is the PyTeal that I created. So now I can right mouse click on that, and I can go and then compile that PyTeal, and it would then go ahead and generate the teal from that. Then let's take a look at this application. So what we're going to do now is create a stateless delegate. So this is a contract to the similar to the contract account that we did, but we're going to do it all visually here. There's a little bit of code that we have in this teal file. So we're going to test the receiver, compare it to our list of in our list. If I go to Algorand accounts and list, it'll list all the accounts that we have. And then if you want to see what the balances are, if you're not sure if you populated it or not, like the last one's not populated, it's got 0, right? We would have to go populate that and see that. So what we're testing for is a transaction from Bob. Bob begins with WCM, and that's the one we're going to be testing for. So let's build this this thing up. So what I'm going to do here is do a new a stateless contract. And we're going to generate a logic sig, okay, on this, on that particular, on that code. So now what you'll see is the ability here to create a contract account like we did, but we're going to use delegated. And the one we're going to have signed is going to be Alice. She's going to be sending it. And then we hit OK here. So now what you see, notice down below, there's the hash. So this is the account. They get the smart contract account. This is the one who's signing it, which is Alice, and you get other information here that was successfully. So we got a logic sig. Now I'm going to take this logic sig that it just created up here, and let's send a transaction. So the first transaction I'm going to try here, this is so nice. This has got everything in here. You don't have to remember anything. I'm going to go to Rust demo instead of Bob, and let's see if this thing works. So we're going to do this. We're going to hit, let's transfer 10 and hit OK. And then we'll down see here on the right is that this failed. Come right over here to the end. Get rid of these notifications. You can see rejected by logic. That's what we were expecting. Same thing. Let's try it again now. Send a transaction. And let's this time, let's go legit. We're going to go to Bob. And, you know, again, if I was to put more than 10 algos, it would fail. Just put 10. You can also create your dry run here. We talked about that for debugging, export assign TX as well, or export the transaction as well, because that could all be used for debugging. So now let's go ahead and hit that, and it was successfully sent. It's pending going to the network, and then we should see a success right there, contract successfully done. So that, folks, is the show. Let's bring back the deck and just go through some resources, and we'll draw our winner for the giveaway for the gift card. And stick around. I want to make sure if you win that I got your correct email, that you entered the correct email address. All right. I talked about foundation reward programs. There are several. There's a developer rewards program and a developer ambassador rewards program. For DevAms, if you submit a tutorial or an article to our site, you'll be part of that program. Then also there's ambassador reward programs for folks that like organize meetups, that sort of thing, do things in the community. There's grant programs if you have a large project in mind, and this is a list of the grant recipients. Look at all these ambassadors. We got over 500 ambassadors now in 66 countries. Quite a community out there. If you're interested in becoming one, give an email to Stephen at Algorand Foundation or visit community.algorand.org. Some great resources on Teal. There's a good video Brian did and our engineering team, also the proof of stake protocol. These are all in the deck. I'll have a link for the deck in a minute. Where's all the code? You've got two repository, the docs repository, and then the hackathon repository. And then that DEX example I showed you is under the smart contracts under Algorand. So in summary, we covered a lot of things here today. The blockchain use cases, the layer one features with, assets, atomic transfers, and smart contracts. The use cases, DeFi, the biggest use case going. A lot of folks are able to also create games now. Gaming is very big on blockchain as well. And then this is the office hours link. So you want to go out to Algorand